Okay, I'm going to play through two amps. One is a great sounding Dumble clone and the other one is a 1/4 watt amp that I built on a small block of wood for a few bucks. Now I'm using the same mics and the same cab. All I'm doing is swapping out the amps. See if you can tell which one is which. That first one there in the demo was the tiny amp that I built, and the second one was the Dumble clone. Kind of nuts when you think about it. So this is the Dumbleton. It's an LM386 build. It runs off 9 to 18 volts and only costs a few bucks. Today I'm going to show you how to build it. If you've ever wanted to build an amp, this is a perfect place to start. It's low voltage, so it's totally safe. There's no lethal power supply voltages, and you can even run it off a 9-volt battery. And at a 1/4 watt, it's still surprisingly loud. Actually, you could use it at a gig through a mic'd up 4x12 cab. That would actually be pretty hilarious. Okay, so at the heart of this amp is this LM386. I use the Dash 4 version because it can handle higher voltage. So that means I can run 18 volts into it for that extra bit of headroom. Now it's been around forever, it's super simple, and it works great. The only other things you're gonna need is a few other basic components, a few capacitors, some resistors, stuff like that. You're gonna need a couple of jacks and a DC input jack as well if you wanna add power to this thing, which I'm sure you're gonna wanna do. And that is basically it. You can also build this inside an enclosure if you wanna make it a bit more robust and shield the electronics from noise, especially if you're gonna start touring with this thing. I just want to talk about the pins because we're going to be talking about the pins on this chip in a minute. I just want you to know which one goes where. On the back of the chip, you can see there's a little dot here. That dot represents pin number 1, and you've got pin number 2, 3, 4, 5, 6, 7, and 8. So it just goes around this anti-clockwise, and that's how you can identify which pin is which because we're going to be talking about those shortly. Okay, so let's build this thing. So for my Workbench members over on my site, I've got a schematic of this for free, and I also have that same schematic in my web shop if you want to check that out. Now you don't need the schematic to build this. It's just there if you like working from a schematic or you just want to support the channel. Now I'm going to show you on a slightly larger version. That was my finished version. Here's the first version that I made. A little bigger, but a lot easier to trace through. Now all I did was put a screw through these ground lugs on this wooden slab here. Now it's actually pretty crazy how quiet this is for the fact it's not inside a shielded enclosure. But I would definitely recommend you do that if you want the lowest noise possible. Now let's go through the signal here. Okay, so our hot lug on our jack goes through a 22 nanofarad capacitor to pin 2. And either side of this capacitor you've got a 12K resistor. They come up from either side and are joined here. And then it goes through a 47 nanofarad capacitor to ground. And this is a ground rail here. So that's the input side of this done. Then you've got pins 3 and 4 on the chip. They both go to ground. And between pins 1 and 8 on that chip, you've got a 1K resistor. That just gives it a little bit of a bump up in gain. That's the gain setting resistor. You can also short that across if you want maximum gain, but I find it can get a little bit too sort of compressed if you do that. The power rail is pin 6, so from pin 6 to ground you've got a 220 microfarad capacitor, so that just is filtering the incoming DC to make it as smooth as we can. Then from pin 7 to ground we've got a 47 microfarad capacitor. Then from the output pin, which is pin 5, you've got a 220 microfarad capacitor all the way to the hot lug on this output jack here. And also from pin 5, I'm just going from the leg of this 220 microfarad capacitor. You've got a 10 ohm resistor in series with a 100 nanofarad capacitor. That helps keep this thing sounding nice and clean, stops oscillations, and stops sort of nasty, jagged sounding clipping. And then I've just got my ground rail going from the ground lug here all the way across to the ground lug there, and all those other grounds are connecting to that. It's just a nice convenient way to connect all the grounds together. So you're also going to need a DC input jack, so you're going to connect the positive lug of that jack to pin 6 on the chip and the negative lug to this ground rail here. And that's basically it. There's no controls, no mucking around. You can do a lot of it from your guitar and it sounds great. I just want to show you my power up method. When I power up anything from an effects pedal to an amp, all my low voltage circuits I do in the same way. So I get my power supply, I'm just using 9 volts for this, and I turn the power on at the wall socket to the power supply. So it kind of charges up that power supply. And then I turn the power off at the wall. So the power supply will be storing a little bit of that power through its capacitors in there. strum my guitar and then plug it in. And you should hear a little bit of sound. So you heard that little touch of sound there. That means things are working and the actual amp is going. If you heard nothing, that would not be good. And then I turn the power on. And there we go, it's working great. So that is my initial startup procedure, and it just means if there is something wrong, it'll only get a brief moment of power, and then you can go and check to see if there's any shorts or any problems. But you should hear that initial little bit of noise, so you know at least it's actually working. It's just a nice, safe way to get it going. Okay, let's see what this thing actually sounds like. Now first, I'm going to show you the difference between 9 and 18 volts. So the 9 volt is going to be a little bit more compressed, a little bit dirtier, and the 18 volt has a tighter low end, a little bit more headroom. So it's sort of a personal preference thing, really. Okay, let's see how it handles a few drive pedals. Now, this is where a lot of these smaller, low wattage amps fall apart. So I want you to listen to how it reacts and how it responds to each one of these drives. It's amazing for something so simple how flexible it actually is. One more really important thing, to get the best out of this, you do need to use some sort of buffered bypass pedal in front of it, or build a buffer in the front end of this thing, because it has a very low input impedance. Today I used a TC Polytune, but you could use any buffered bypass pedal like a Boss or something like that. That will work great. Now obviously this isn't replacing a real Dumble, but for $5, it's kind of crazy how good it sounds. And if you've been curious about building your own gear, start here. It's simple and it's safe, and it opens a whole new world of DIY, which is freaking addictive, just saying. Anyway guys, have a great week and we'll catch you in the next one.